Insertion sort. What is an insertion sort? Insertion sort is a sorting algorithm. It is sorted by left to right starting from the first number. A value/object keeps moving until it has found its right spot/position. This algorithm can include an operation called a swap operation. Swap operation swaps two values. So for example, xy to y to x. Example, we have these values 5, 3, 2, and 1. The number moves when there is a smaller number on the right side of it. 5 is greater than 3, they swap position. 3 is less than 5. Once a value is stored at its proper position, it is time for the next number to move. Now 2 is on your left and 5 is on the right. 2 is less than 5 and the number beside 5 is 1. Then 5 and 1 swap position. After that, 2 and 1 swap position and 3 and 1 also swap position. After that, 3 and 2 swap position. At the end, it will look like this: 1, 2, 3, and 5. Advantages versus disadvantages. As for advantages, 1. This algorithm is efficient for small quantities to sort. 2. It has a simple implementation. And 3. As the quantity decreases, the performance increases. Disadvantages. 1. It is not efficient with large quantities. 2. With more quantity, it has a harder implementation. And 3. As the quantity decreases, the performance decreases.
I'll be showing you a real-life example of how an insertion sort works. So as you see, all these books are not in any type of order. They're just scrambled up. We will be sorting them from the shortest length to the longest length. So this is how insertion sort starts. It goes to the first object and it says that it's in the right position, and then it moves on to the next object and then it compares it with this. And it says this object is smaller, which means it pulls that object out, the big object moves over, and the smaller object moves down. Now the Java now thinks that both of these objects are in its original position, and they're in a right order, until it moves on to the next object, and it determines that this object is also smaller than this, which means this object gets pulled out, the larger object gets moved on, and the smaller object gets placed. Now, once again, Java thinks they're all in order until it moves on to the next object. So it compares the two objects and it says this object is smaller than theirs. So the small object gets pulled over, the large object moves on, and the small object gets put in front and then swaps the position with the large object. Now finally, it goes to the smallest object, and it goes to the last object, and it compares it with everything, and it shows that this is the smallest object. It gets pulled out. All these objects before the object that's pulled out gets pulled over on one spot, and this one goes first.
Hi guys, now I'm going to start explaining the Insertion Sort program. So first off, this program is to sort the array into least to greatest. So let me write it down: to sort the array into least to greatest. And the param. So the parameter. So the parameter list that you take in is array A. Well, in my case is int array A. So let me go int array A. And so the reason why you're inputting one array is because it wants you're sending that array to be sorted. So is the array you want us to sort. So now we have one for loop here, and this for loop is supposed to start with 1. So it says int I equals 1. The reason why it starts with 1 instead of 0 is because you're assuming that 0 is sorted already and you're starting with 1. And here is your temp value, and your temp value is every a.i. So every element, indices or element that you have, that would be your temp. And when you go down, and this loop is the actual loop that actually sorts out the method. It says j equals I minus 1. The reason why I said that is because it's to check if the value to its left is smaller. So for example, if on your left hand side there is 5, on your right hand side is 2. Obviously 5 is greater than 2, so it's going to swap position. This is what this for. And this j is greater than -1 is to give us an array index out of bounds exception error. So to avoid that, we have this code. And this part of the code is to check if temp is greater than a.j. So we know that our a.j is if your a.j is greater than temp. So you know that your temp is one number higher than in your array. So and your a.j is I minus 1. For example, if it's 2, it's gonna be 1. So what, for example, if on your, again, same example, if there is 5 on your left hand side and 2 on your right hand side, you know that they're gonna swap position because 5 is obviously greater than 2. And this case is j minus minus. The reason why it's j minus minus is to replace the lower number, which is the higher number. And this aj plus 1 is to, because we minus j is equals I minus 1, we have to add 1 to get the actual number. So if I is really 2 and I minus 1 is equals to 1, so we have to add 1 again to equals to 2, and that is equals to a.j. And you obviously want to store that, and you obviously want your temp value to point it back to your a.j. So this is what this line of code is for. And now let me just test it out. It is print. Oh, I even have a print table method too, so that's what I'm calling. So I'm using the value. So my test array is going to be 5, 3, 9, 7, 1, 6, 0, -1, and 3. Let's try sorting it first. So compiles, and let's run it. So it says over here, table before sorting it is 5, 3. It says the unsorted one, and after I call the array, like after I call the method, see I call this, so insertion sort bracket test, and I'm also going to print it out as a table, and this is the actual table, and so it's sorted. So see, it starts from -1, 0, 1, 3, 3, 5, 6, 7, 9. And let me try rearranging this. Let me try messing up this one. Let me start with 4, 5, 6, 1, 3, 6, -1, and 10. And let's try with this. Compile. It compiles and check if it is. See, once again, this table, the one before that is showing which was before it's sorting. So it's 4, 5, 6, 1, 3, 6, -1, and 10. So it starts from -1, 1, 3, 4, 5, 6, 6, 10.